ultimately, it has to have three attributes, and that is simple, intelligent, and it needs to be adaptable. By adaptable, we mean that it needs to be flexible enough to be used in multiple different scenarios and ways, and give you a long lifespan for your operations and for your technology and design choices. So let's dig a little deeper into the data center capabilities that are important for you to create insight and information about this. So on the first side, we talk about automation, and that obviously creates the simplicity for your operations. Later on, we will talk about the intelligence in the network and how visibility can help you to create information and extract information from your network to deliver you important decision-making data and information. So let's move forward. So if you look at the life cycle in a data center, there are a couple of very different things that you have to do. So first of all, you have day zero provisioning. That is when you first enable and turn on your network and your data center fabric. Then you have to configure a lot of parameters and a lot of things in order to have them all behave as one infrastructure and one fabric, right? Later on, what you need to do is, and this is referred to as day zero, sorry. And later on, throughout the lifetime of your operations at the data center, you have to provide tenants and users and fabric-wide services throughout your data center to ultimately, as mentioned earlier, give those applications the means to run smoothly on this. And what we want to do is we want to really automate and simplify both tasks. So day zero as well as day one. And day zero does not only pertain to just bringing up the infrastructure at the beginning, but also when you add new leaf switches, when you expand the deployment of the data center, you also need to kind of make sure that those devices are properly inserted and properly integrated from a configuration perspective into your infrastructure. So ultimately, there will be a number of things that we can do for you. So the whole infrastructure and inserting new switches will be a matter of seconds, as there will be a lot of things done automatically. But you will also be able to adapt to your requirements, and then obviously also the subsequent service-related tasks that are relevant for your end users and for your services will also be done throughout the Extreme Fabric automation that we're going to talk about here. So let's quickly look at this. So eventually you have an infrastructure in your data center that will be your leaf and spine switches that actually comprise the fabric, right? But what you do is you basically put together a couple of design principles that are best practice for operating a data center and building a infrastructure with the deterministic performance in your data center. So you put all of this together, and that is your physical infrastructure. Then you have a layer of automation that we kind of talk about in a couple of slides, and that will communicate to the fabric for automation purposes. But here you also have interaction with a couple of adjacent components, such as vCenter from VMware, OpenDaylight, OpenStack, some ecosystem partners here. And this is where you kind of get a lot of the data that is important for your services to be available. And then north of that, you have additional tools that go beyond the network, but will benefit largely from the abstraction provided by Extreme Fabric automation for the network infrastructure. And this might be something like a third-party management system or an OSS system that takes care of your whole customer lifecycle, or you just automate certain workflows that will also include security, firewall rules, for example, or server provisioning, and all these kind of things. And what we're talking about here is that we provide you a level of abstraction, a single point of interaction for the fabric as a whole, as one abstracted entity, and you don't need to deal with individual components anymore. As all modern softwares these days, Extreme Fabric automation is based on microservices with containers and everything to provide a very flexible infrastructure, and it can be very flexibly deployed either as a service on the network itself in case you don't want to run additional appliances, or if you have full control over your management infrastructure, you can also run it externally on a dedicated management server that will then handle the tasks in a very scalable way. So what do we do? So obviously, as a network with network elements, we have a couple of resources that we need to manage. So we have physical ports, right? But those ports we kind of group together and we create entities such as port channels or trunks, depending on what technology or terminology you're using. Next up, in the stack of abstraction, we configure endpoint group, which is by and large identical to a VLAN on the device, a bunch of ports that belong to the same kind of network or broadcast domain if you want. And then we want to bring all of this together to form one network or multiple networks, but we don't stop there. We also want to configure VRFs and routing on the network itself. So all of this we want to expose and abstract and expose to the end user and also to those external systems that can make use of this abstraction. So if you look at this, so if you look at the fabric itself, and if you adhere to those best practice design rules, it is really only like 30 or so parameters, such as a range of AS numbers, a range of IP addresses to provide addressing for your devices and stuff like this. And that all totally describes the fabric itself. And the only other thing where you really have to or want to spend your time is provisioning services to your customers. And even this is what we want to automate with this. Now, obviously, we want to integrate as much as possible and give you, let's say, the services as fast as possible. And this is, again, just one example because it is the market leader here. And the idea here is that the application and virtualization layer here is managed through a vCenter instance, for example, right? And vCenter communicates the actions, activities in the virtualized infrastructure on a message bus that we subscribe to. And basically, we have a dedicated microservice component within EFA that actually interacts with the vCenter, right? And with this, we don't have to poll the vCenter every time in a certain time interval. What we do is we just subscribe to the message bus. And now whenever an event happens, such as a VM creation or a VM move or a delete or something else, then we get automatically informed. We also built the topology between the hypervisors and the bare metal servers connected to the network through appropriate mechanisms. And this means that when a VM move is being initiated by vCenter, the event is being distributed on the message bus, we take this event and we make sure that we create the appropriate network level configuration on the new device or the new leaf device that the VM is actually moving to. So this way, this gives very seamless integration and very seamless mobility for those virtual machines in the data center without any interaction with the system other than the upfront kind of integration with the vCenter infrastructure. So next thing we want to look at now in a highly virtualized world is how do you gain visibility into your data center, and how do you create enough intelligence to make smart decisions and actually operate your data center efficiently. So first of all, let's look at a number of ways to extract data and gain insight. And let me start from the top right here. So one such area is network packet broker. It is becoming increasingly interesting for data center operator. But what it does basically is you identify a couple of important places in your data center where you want to extract information from, key information from. Then you look at all the data that is passing through this place in the network. And then you create a copy of it without interfering with the original production traffic to begin with. And the original production traffic is this arrow here, right? But then you create a copy of all your flows that are passing through this link, through this place in the network, and you create the copy to a dedicated infrastructure that would be referred to as the network packet broker infrastructure. And this infrastructure gives you the capability of doing scale-out analytics of the data. Because obviously with this approach, you create a lot of data and you look at a lot of data. But the good thing is that you can send this data to a lot of different tools for a lot of different purposes. You can send multiple copies to different tools. You can filter out what you send to a tool, and essentially it helps you to manage the amount of data to those monitoring and tool appliances. So this is, let's just say, the most amount of data that you look at, and hence the most amount of complexity to actually inspect all the data. And this is why here in this kind of little icon here, it means that we look at all the red traffic here, basically, and we have a lot of data at our disposal to analyze. Another thing that we can do is what we refer to as application telemetry. So what we do here is we just look at key components of your communication and just give an example. For example, if you initiate a TCP session, the first 3 packets in the handshake, that already tell you a lot about new flows being generated and new sessions being initiated. So if you just look at those 3-way handshake, for example, and maybe a handful of other communications such as DNS, DHCP, and maybe certain HTTPS requests, but not the subsequent large amounts of packets, we only have to look at a small amount of data, but we can get a huge amount of insight as to what kind of applications are running in our infrastructure and so forth. So that is really an efficient way. We lose a lot of the, let's say, visibility into the remaining parts of the communication, such as how much data is being translated and so on and so forth. But we have a lot of insight, and that is a much lighter on processing, and can really be considered as an always-on kind of monitoring opportunity here for your infrastructure. On the top left here, we have what we refer to as insight architecture. So basically, the most common use case is that once you have identified that you want to look at some of your flows in particular, so let's just assume you still have a lot of communication in the data center, but most of the communication is not important to you, at least not right now, but you really want to look deep into one such flow. Then you can use something like insight architecture, and just redirect some of that or this flow or this communication to the inside architecture, and I'll talk in a little while about how you do it and what would be needed in your device to actually do this. And then you inspect it here in much more detail. And the fourth way of creating important information about the infrastructure is through something like streaming telemetry. They don't really look at the data per se that is being transported by your devices. So your flows are basically transmitted without any interaction, but you look at the metadata of the switch, like BGP state, CPUs, the state of your queues, the interface statistics, the actual loggings, and so on and so forth. And from this metadata, you infer a lot of information for your decision-making process. Now let's look at the internals of a distributed system today, right? Imagine this is your network element here, right? And like I said, automation is done, through northbound interface, but still, you need to have a way to pass your traffic, and this is typically done by, a kind of decentralized forwarding through a packet processor, and you have traffic coming in, traffic going out, without any of the central resources of the device having to interfere with it, right? Oops, sorry. Now, control packets, obviously, something like BGP updates or these kind of things will come to the system and need to be maintained by the system VM. But then you also have the opportunity in a modern system to actually look at additional data through dedicated infrastructure. So basically, we have a dedicated path from the packet processor, decentralized packet processor, into the onboard resources that are dedicated to what we refer to as guest VM or third-party VM. And this analytics path, like I said, has no competition to the control plane aspects of the device itself, right? And this is what I referred to earlier, where you say, assume you have a specific conversation or communication that you need to look at. You just instruct the packet processor to send the data up here, and then you have co-located to each device the infrastructure to look at the data, to store it locally, and then you might have automated ways to actually make it available at a central place for viewing. And that is, that gives you a lot of visibility into, specific flows but also for, let's say, if you need to look at it in multiple places in the network. So this arrow here is the data streaming or streaming telemetry part. So this means that we have an ongoing stream of data, metadata, that we send to large data crunching applications such as Splunk or New Relic or stuff like this for additional analysis of the data. That can be sourced from the guest VM, but also from the system VM itself, as I mentioned earlier, right? And now with all these sources of information, I come to my last slide. With all these sources of information, you can now apply machine learning and AI technology to actually look at certain things such as, for example, IoT security by detecting anomalies within your infrastructure, and whereas the device behaved in a certain way for the last 30 days or so, suddenly there's something different that might just flag an alarm. It would be too small to be noted by a human, but ML and AI are perfectly suited to find those kind of things. Then we might just find for efficiencies in your network and optimize certain settings and certain parameters. We might also be looking at trending of parameters such as your digital optical monitoring data to predict failure of optics or CPU of devices, and proactively initiate RMAs for these kind of things, or reroute traffic or something like this. But you also can identify environmental issues. For example, if you have anomalous behavior of certain devices, and you can correlate it to certain events. And last but not least, you can just very generally mine for certain parameters, and for example, see whether you have certain links being notoriously overloaded in your network. So with this kind of intelligence and this insight, you have a lot of tools available to optimize your network and have better operations in total. So this was my last slide. I want to end here and pause for potential questions you might be having.
Thank you, Jürgen. I don't know if there is any questions.
So let me just check the Q&A. Okay. So yeah, I can't see any questions. If you find that you have questions later on, so don't hesitate to reach out to us. You saw my email address on the first slide, on the introductory slide there. So you can always reach out to us, to Extreme. And thank you very much for your attention. With that, I hand back to Mauricio, please.
Thank you very much, Jürgen, and thank you very much for your workshop. And so I think that that's it for this workshop. If you want, we have another workshop that is starting right now in another Zoom room that you can find on meeting.namex.it at the session workshops. Thank you very much to everybody.
Okay. Thank you. Bye.
See you soon in person, I hope.